Okay, let's try this geometry problem here. Here we've got a big circle and a whole bunch of things going on. You should always read this stuff really carefully because sometimes the answer to the question's in there and you haven't read it properly. So make sure you read it really carefully. I'm going to do it a little quick though. I know that that's a tangent line. I know I've got two parallel lines there. They've told me this R2 is 10 degrees and that's 20 degrees, and they've given me that parallel line. I know that those two lines are equal, that's a line from the center. So the line from the center is bisecting the chord, which means something about that angle there. And that's kind of it. I also know that this is a cyclic quadrilateral. These points are on the outside, and well, let's just get started here. We're supposed to find S1. Well, here's an angle. They didn't put a line between R and Z, but O1 and S1 open up to the same segment. But this is an angle at the center, and S1 is an angle at the circumference. So S1 is 10 degrees because the angle at the center is 2 times the angle at the circumference. So there's S1 is 10 degrees. Now the next one's pretty easy. How big is R3? Well, I'm looking at this Z here and parallel lines, and you've got to know your stuff from way back. Alternate angles, and then you have to state that RQ is parallel to YO, and that's R3. Let's try angle P. Angle P, well, I knew that was 10 degrees. I write it in as you go along. It gives you more information to do the next things. I know that's 20 degrees because of alternate angles. Now, I see a cyclic quad. The hard thing is kind of focusing on the stuff that is going to give you the answer without, there's so many triangles and lines going all over the place. You've got to focus on here. You might use a colored pen or something and just go right around PQRS, and then say, the opposite angles, that P is going to have to be 150 degrees because it's got to add up to 180. Opposite angles of a cyclic quad. Okay, S2, and they're telling me it's 4 marks. I've got to get it this somehow. But, what's the story about an angle from the center to a midpoint? Angle from the center to the midpoint. Well, that's got to be 90 degrees. But hey, you know what? We're going to save that one because we know that this is 90 degrees. We know that this is 90 degrees. XRO is 90 degrees. R3 plus R4 is 90 degrees because a tangent is perpendicular to the radius. Okay, that's a better one. There's more than one way to do things here, but that makes this 70 if it's got to add up to 90 degrees. Now we know this is 70. But what's the story about the angle in between a tangent and a chord and the alternate angle up here in the triangle? It's equal to S2. That's the tan chord theorem. So that's got to be, S2's got to be 70 degrees because the angle between the tangent and the chord equals the angle in this opposite alternate segment. So part of the triangle, right at the top of the triangle. So that's the tan chord theorem. Well, there you go.